Hey everyone, SwiftScripter here and welcome back to our Unity scripting series. In this video, we'll explore Unity components and game objects. We'll look at some essential components like Transform, Rigidbody, and Collider, and how to manipulate them using code. So yeah, let's dive right into it. I mentioned this in the Unity game engine series, but Unity components are the building blocks of game objects. They each add some specific functionality to the game object. Yeah, let's explore some of the used components, the most used. For one, I'm in this project right now, still going off of last video. The first component we're gonna go over, like how to code, is the transform, this component. So this basically defines the position, rotation, and scale in the 3D space. Each game object has a transform, so even this has a transform, which I added. Directional light also does, main camera also does. So every game object by default has this. And we're gonna use scripting to edit the transform. So I'm gonna create a new script called move object. I'm gonna attach this script to the cube. Now I'm gonna open it. So we're gonna go in the update method because it's called every frame. And the method we're gonna use is called transform. So the transform of the game object that this script is attached to dot translate vector3.forward times time.delta time. Now what this does is make sure the movement is smooth, and what this does to the game object is moves it forward along the z-axis. So if we hover over this, okay, I'm gonna fix this real quick. So yeah, anyways, if we hover over this, we can see that on the z-axis, it's where the value 1 is. So that's why it's going to edit this value. It's going to move it along the z-axis every frame, so it creates a continuous movement. So let's see what this does. So I'm going to press play. Yep, and it's moving. Something else I'm going to do is actually move it all the way back. See what it does. Go back to scene view. And it keeps moving it that direction. So that's what the translate does. No matter what x-axis it is, it's gonna keep moving it in that direction because it's the z-axis, because we're not changing anything in the x or y-axis, but that's pretty much how the transform works. The next thing we're gonna do is edit the rigid body, make this move the game object. So using scripting, it allows a game object to be affected by physics, like gravity as you saw earlier, and collisions. So since we already have a rigid body added, I'm gonna add another script called apply force to demonstrate force being applied, which is, common sense. You can just tell from the name, but apply force. And all right, so something we wanna do before all of this is have a variable, which I went over in the last video. We're gonna have a float called force to determine like how much force, how powerful you want the force to be. The public basically means it's accessible through Unity. So I'm gonna actually save this, show you how it looks in Unity. Now since it's public, I actually didn't add the apply force yet, but I'm gonna do that right now. See, now that it's public, you see this variable here. But if we go back and make this, we use a keyword called private. If we make it private, then it's not visible anymore. So now you see the point of like why it should be public, why it should be private. And what we're gonna do is actually get the rigid body component, because this actually is not in the game object by default. So we're gonna have to get the component, the rigid body component in the code. The way we do this is by doing rigidbody rb equals get component, and it auto completes for you. Just press tab to enter. And then what we'll do is in the start method, we're gonna do rb.AddForce vector3.up times force. So basically it multiplies. So this vector3.up basically is being multiplied by the force, which is 10 in this case. So it's gonna be moving on the x-axis. 0 times 10 is still 0, but 1 times 10 is 10. So it's going to move on the y-axis, and then 0 times 10 is 0, still on the z-axis. So x and z-axis are not being impacted at all. It's only the y-axis. Now we see something here called force mode impulse for this Rigidbody AddForce method. So I'm going to complete this and explain what this does. So basically what this does is it applies an instant force to the rigid body using its mass. And this type of force is suitable if you want to apply like a sudden force, like a jump or collision impact. There are actually several types of force modes, and I'll show them all. So one is called force. So this adds a continuous force to the rigid body. And then acceleration does the same thing, except it does not take into account the mass. And then we also have velocity change right here. And as you can see, it explains what it does. It also does something similar to impulse, except it doesn't take into account the mass. So I'm just gonna type force mode.impulse. I'm gonna save this, go back to Unity, and we can edit this any way we want. I'm just gonna leave it at 10. And as you can see, it applied that force instantaneously. The next thing we want to go over is collider. So there's several types of colliders actually. What they do is it defines the shape of the game object you're working with. So in this case, I added a box collider. Usually by default, when you add a cube, the only things it's going to have is a box collider and a transform. Whereas for the rigid body, you'll have to add that, just type rigid body. So notice the difference in what's already there by default. That's why we have to do get component for this rigid body. Whereas for the box collider, you can guess that we do not have to get the component. Unless, of course, you add another collider. So there are several types of colliders. In this case, we're using a box collider because it's a cube. When you go to the code, so for the collider, there's actually a default Unity method which you can edit. For this, it's avoid on collision, enter. And as you can see, this thing is already popping up. So for Unity, there's a default on collision, enter. So if you type this and press, notice it's already showing up. So just double click on this. We already have something here. Basically what this does is edit what's gonna happen when you're gonna collide with another object. In this case, I'm just gonna do debug.log collision detected with, I'm gonna do a plus sign, and we're gonna wanna find the name of the other object we collided with. So in our game, we're gonna collide with the plane. We're gonna collide with this thing. So theoretically, before I print this, it should print, sorry, I'm used to saying print. It should log the name of this object in our hierarchy, should put that in this console. So when we press play, as soon as this game object lands, okay, that's not working. Oh, it's because did I add the script? Nope, I did not add the script. See, this is the problem with me. I make stupid mistakes like this. So you're gonna wanna add the script to the game object. In this case, we're doing the cube. So now it should, yep, there it is. Collision occurred with the plane. There we go. Now I wanna talk about game objects. In the Unity game engine series, I actually went over everything like about it, what they are and things like that. But there are also several important properties I'll cover in this video, which we can access through the inspector, such as the name, this name right here, the tag, as well as the layer. So I'm gonna actually create a new script called GameObject Properties. So GameObject Properties. Now I'm gonna open that, and here I'm actually gonna type this GameObject, which is a class by itself, and I'm gonna say something like GameObject go equals new GameObject my GameObject. What this does is basically adds a new game object in our scene as soon as we press play, and we can set this up, set this game object's properties up by doing like go.tag equals, we can say player in this case, and then go.layer, and we'll want to use something called layer mask.name to layer, which sounds really complicated, but really what this does is just access the layer name, the layers we already have in our game. So I'm going to add this to our cube. And when we press play, adds a new game object. And let's pause. Its tag is player and its layer is default. We created a new game object by attaching it to another game object, attaching the script to another game object. Now let's create another script. So actually, I'm gonna delete all of these scripts. I'm gonna delete this and delete these three. Now we're gonna get hands-on and create a simple script to manipulate the game objects again. We'll create a new script in this folder and we'll call it GameObject Manager. So let's open this. Let's open the script. And now what we're gonna do in this start method is create a new game object just using script. So we're gonna do GameObject cube equals GameObject dot create primitive, and it auto completes this. We're just gonna add a new game object of the type cube in the scene. So I'm gonna press tab for all this. And then we're gonna add a Rigidbody component to that cube. So cube.addComponent. It is not mesh filter we want Rigidbody. So tab, enter. And now we'll also wanna set the position of this cube. So cube.Transform.Position equals, and we use this new keyword because we're creating a new game object and we didn't set up its transform yet. So it's a new vector, 3, 0, and I'll say 5, 0, so that will be up a little and then we can see it fall down. And then we'll change this cube name, cube.name equals falling cube. So save this. Go back to Unity, attach it to this new cube we made, and then in the scene, it's actually gonna create another cube. So we're gonna press play on this bad boy, see what it does. Ooh, just landed straight on top. So yeah, that's pretty much it for this video. We covered Unity components like Transform, Rigidbody, and Collider. We also explored the basics of their properties, how to create and manipulate the game objects, using scripting. So in the next video for this series, we'll dive deeper into player movement and input handling. But yeah, thank you guys so much for watching, and I'll see you guys in the next video. Bye.